In this video, we're going to learn how to calculate the mass of a single atom or molecule. What is the mass in grams of a single atom of silver? To solve this problem, we're going to have to pull in a few different pieces of information about moles. The first is going to be about mass, because we're talking about the mass of silver atoms here. So what do we know about the mass of silver? Well, we can look it up on the periodic table. And this number here, 107.9, tells us the molar mass of silver. It tells us how much 1 mole of silver weighs in grams. So we can say that 1 mole of silver atoms weighs 107.9 grams. Okay, so that's what we know about the mass of silver. We're not talking about a mole of silver here, though. We're talking about a single atom of silver. So what do we know about, say, like the relationship between moles and the number of things in a mole? Well, we know that 1 mole of silver atoms contains 602 hexillion silver atoms, and this is often abbreviated as 6.02 times 10 to the 23rd silver atoms. Now, to solve this problem, we want to take these two pieces of information and combine them to make a third piece. It's going to be the most useful for us, okay? Here are the two things we know, right? We know that 1 mole of silver atoms weighs this much. And we also know how many silver atoms, 602 hexillion, are in 1 mole. So from these two pieces of information, we can say that 602 hexillion silver atoms, 1 mole, weigh 107.9 grams. Okay? So now we know how much this number of silver atoms weigh. Okay, we can even write this as kind of an equation, a relationship, an equivalence. And from this relationship, we can write two conversion factors. One of these has grams on the top, one of these has grams on the bottom, but both of them can let us convert back and forth between the number of silver atoms we have and their mass in grams. So we work through these pieces of information, we're able to write this equation that then lets us write two conversion factors that let us go from the number of silver atoms to grams. We will use one of these conversion factors to go from 1 single atom of silver to how much it would weigh in grams. So let's see how we'll start that out, okay? We're going to do a conversion factor problem where we start with 1 silver atom, 1 silver atom. And we're going to want to multiply 1 silver atom by one of these two conversion factors, and the one we're going to choose is going to be the one that's going to cancel out silver atoms, which is on the top on this side of the equation. Okay, so it's on the top here, we're going to want it on the bottom. So this one's not going to work because silver atoms is on the top, but this one is the one we want. Okay, so silver atoms on the top cancels out, silver atoms on the bottom cancels out there, and it's going to leave us with grams. Now that we've written this out, we can solve it with a calculator. You can type it in like this. We will get this out as our answer, which is just the calculator's way of saying this number times 10 to the negative 22nd. And all we have to do now is just round this using significant figures, because calculators don't do rounding. We're going to round this to 3 significant figures. We don't worry about the number of significant figures in the 1 because it's a counting number. It's not a measurement. So we're going to do 1.79 times 10 to the negative 22nd. What are the units here? They are grams. And that is our final answer for the mass of a single atom of silver. And just to show you this, not in exponential notation, here is a decimal point, and all the way over here, 179 grams. This is a tiny, tiny, tiny number. It is how much a single atom of silver weighs. Now let's look how to do this with molecules instead of just atoms. What is the mass in grams of a single molecule of water? This is a lot like calculating the mass of a single atom, except there are just a couple extra things to keep in mind. Okay, so here's a water molecule, H2O. It's made up of 2 hydrogen atoms and 1 oxygen atom. The first thing we want to do is figure out the molar mass of H2O. Okay, we want to know how much a mole of H2O molecules would weigh in grams, okay? So to do that, it's made up of hydrogen and oxygen, so we look up hydrogen and oxygen on the periodic table. Here's a molar mass of hydrogen, here's a molar mass of oxygen, and we're going to add them up, okay? So there are 2 hydrogen atoms in water, so we do 2 times the molar mass of hydrogen. And then there's one oxygen atom, so we do 1 times the molar mass of oxygen. We add this up and we get 18.02, which tells us the molar mass, and it tells us that 1 mole of H2O molecules weighs 18.02 grams. Now we know how much a mole of H2O molecules weighs. In order to convert back and forth between number of molecules and mass, we need to know a little bit about the number of things in a mole, which is 602 hexillion H2O molecules in 1 mole of H2O molecules. And as we did before with silver, we can combine these two pieces of information to say that 602 hexillion H2O molecules is 1 mole, and it weighs 18.02 grams. We can express this as a relationship, and we can use this to write 2 conversion factors. Both of these are based on this equation. It's just one is the flipped version of the other. Okay, so we got these 2 conversion factors that we can write from this information here, and here's how we'll use it. Okay, we're starting with 1 H2O molecule, and what I want to do is multiply that by the conversion factor that's going to get rid of H2O molecules. So I'm going to want to use the one that's with H2O here on the bottom. So H2O molecules cancels out, H2O molecules cancels out there. It's going to leave me with grams. And when I go through and do the math, rounding to 3 significant figures, I'm going to end up with 2.99 times 10 to the negative 23rd grams. Here's just how you'd plug it into your calculator and the answer that you'd get. And finally, I always just like to emphasize that this number here isn't just some like weird Martian number with this 10 to the negative 23rd, but it is actually a very, very tiny number that if you had the time could be written out with lots and lots and lots and lots of zeros. A tiny, tiny amount in grams, the mass of a single molecule of water, H2O.